Welcome to lesson 10-6, secants, tangents, and angle measures. Quick reminder, tangent means a line that intersects a circle exactly once. This new word secant is a line that intersects a circle twice. So if we just take a chord and extend it into a line, we'd call that line secant. All right. So, on this picture, I'm wondering what angle 1 measures. It's not going to be 60 degrees because the vertex of the angle is not at the center of the circle. It's not going to be half of 60 because the vertex of the angle is not on the circle. The vertex of this angle is just somewhere in the circle. And we can figure it out like this. I'm going to add an extra chord to create a couple of angles that I do know how to handle. So we all should know how to get this angle. Vertex is on the circle. This angle is going to be half of 60, 30. And we can get this angle. Vertex is on the circle, so this angle is going to be half of 100, which is 50. Finishing off the triangle, that missing angle has to be 100 degrees. And angle 1, therefore a linear pair with the 100, would have to be supplementary, answer 80 degrees. Slightly faster way to get angle 1 is to use the exterior angle theorem, which I'm going to quickly remind you about here. On any triangle, if we know two angle measures, we can get the third one, so these two add up to, 116? So 64 left over, and then the linear pair to that 64 would be 114. But really remember, the exterior angle of a triangle is always going to equal the total of the two remote interior angles. So even without calculating that, I can get the exterior angle by adding these together. So I could have done that here. I could have said angle 1 is going to be just the total of these two, which is 80. I'm going to try that again, point something out to you. All right, so same thing. Now I want to get, I'll call it angle 2. So this angle on the circle is going to be half of x. It's going to be x over 2. This angle on the circle is going to be half of y over 2. So angle 2, which is the exterior angle of this triangle, turns out to just be the total of these two. And when you add these fractions together, x over 2 plus y over 2, we get x plus y over 2. And notice what that is. On the original picture, x was the arc from the original angle, and y was the arc of the vertical angle. And all we're really doing is adding them up and dividing by 2. So if you go back up to that first picture, even before I drew that chord, angle 1's arc is 60. The vertical angle has an arc of 100. If you add them up and divide by 2, we get that answer 80. So that's how we handle angles with the vertex inside the circle. How about outside? So I'm just going to go right into the proof on this one. So if I want to get angle 1, it can be done using these two arcs, the two arcs that are inside the angle. So we don't really care about this arc, we don't care about this arc, we're going to use these two arcs. If I were to draw one extra chord, we're going to create a couple of angles that we know how to handle. We know how to get this angle. It's on the circle. This angle measure is going to be half of x, or x over 2. This angle is on the circle, so its measure is going to be half of y, or y over 2. And if we look at this triangle, notice there's an exterior angle. We could write this equation the measure of angle 1 plus y over 2 is going to equal the exterior angle of x over 2. So I'm using that exterior angle theorem again. The measure of the exterior angle for that triangle, which is this angle, x over 2, needs to equal the total of these two angle measures. So if I want to know what angle 1 is, which was the original question, I would just subtract y over 2 from both sides. And that's going to turn the equation into x over 2 minus y over 2 equals the measure of angle 1. And we can combine those into one expression, x minus y over 2. So we just showed from that original picture, when the vertex is outside the circle, if this is x and this is y, the measure of that angle is this arc minus this arc divided by 2. The previous problem, we had the vertex inside the circle, and the only difference is in that case we saw you add the arcs and divide by 2. When it's outside, you subtract these arcs and divide by 2. And of course we need to get a positive angle measure, so we always want to do the larger arc minus the smaller arc divided by 2. The larger arc is always going to be the one further away from the vertex, because the further away we go, the wider that angle gets. So the large arc minus the small arc divided by 2. Back over here, I will leave it to you to maybe challenge yourself to see if you can do a similar algebraic proof for yourself by adding an extra segment from here to here. But it turns out even if one side is tangent and the other side is secant, if I wanted to get the measure of angle 3, see if you can prove to yourself that it still works out to be this arc minus the other arc inside that angle divided by 2. The big arc minus the small arc divided by 2. So I made a little summary sheet that I'll be attaching to either probably Google Classroom, but I'll get it to you somehow. It's going to look like this. And this summarizes how to get all the angles in and around circles. If the vertex is at the center of the circle, this goes way back to before school got sent home, the measure of the angle is equal to the measure of the arc. If the vertex is on the circle, like here or here, whether it's two chords or a tangent in a chord, the measure of the angle is going to be half of the arc divided by 2. Same in this situation. And what I was just showing you today is what's on the back of the second page of the attachment I'll send you. If the vertex is in the circle, and you want to take the arc and the vertical angle's arc, and you want to add them and divide by 2. And finally, when the vertex is outside the circle. In all three cases, whether it's two secants, a secant and a tangent, or two tangents, if that vertex is outside, the way you get the angle is the larger arc in the angle minus the smaller arc in the angle divided by 2. It works in all three cases. So I'm going to stop this video in just a second, and then I'll come right back with a whole bunch of example problems so you'll be able to try your assignment.